Hi, today we're gonna talk about semaphores in Rust. So let's pretend we have a limited number of expensive resources. Those could be database connections, for example. And here we have four resources and we have 10 customers. And those customers want to consume those resources. So we want to run this code in parallel. So while one customer is consuming one resource, another customer can also consume their resources as well. But we want to have some control here. We want to run this code in parallel concurrently, but at the same time, we want to avoid those customers to consume the entire pool of resources we have. So in order to solve that problem, we can use this semaphore concept, and I'm going to using this here with Rust and Tokio to execute this code in concurrently and to show you how to use this concept to handle this problem. So let me try to move this to the code here and make a zoom here so you can see that better. So the first thing I'm gonna do is import some libraries I'm going to be using here. So the first one is the standard library. We have to use the arc. Uh, if you don't know what arc is, it stands for atomic reference counting. It's a smart pointer that allows multiple reference to data while ensuring thread safety. So you can think of it as a way to manage shared ownership of data across multiple threads. So we're going to be using this arc here, and I'm going to use the semaphore. So the Tokyo sync um, semaphore. We also are going to be using the sleep and duration. So let me add this here. Time and to use sleep and duration here. Okay. So I'm going to create an enum here to represent the resource that I want to share. Let's pretend this is a database resource, but I'm going to use an enum to represent it here. So this resource is a database resource. Okay. So I'm going to create some function that's going to represent the access. So I'm going to create an async function that's going to run concurrently while is accessing these resources that I have to share here, that I want to share here, sorry. So this async function, I will call that access. This is going to receive our semaphore, the resource, and maybe some service to represent the service that is accessing this resource. So this is a semaphore, and it's going to be the arc. So our atomic reference counting with the semaphore here. We're going to receive the resource. This is going to be a reference to the resource we are sharing. I put the underscore here just well, I'm not going to use the resource in reality. This is just to represent I'm sharing this resource here. But for real codes, you're probably gonna use this. So that could be your connection or some files or something you want your client or service have services have access to. So this service, I'm going to use a string just to give a name to it. So the first thing I'm going to do here is print line, and I'm going to print here this service is using the resource, or here actually is awaiting to use the resource, waiting to use the resource. Okay, and I'm gonna put the service here, and let's get our semaphore. So we want to acquire the semaphore, so that's going to permit the service to use the resource, so to speak. So let permit is equal to semaphore acquire, oh wait, and since this return results, let's unwrap this semaphore here. So I'm acquiring the semaphore, and let's add some sleep here. So this is going to wait for 2 seconds to simulate something is going on here during this permit. So, and duration from second, and let's add the seconds here, and I'll wait. So let's pretend the service is using the resource now, is using the resource, and now let's simulate more time here. Let's pretend while this service is using the resource, this is gonna take some time. So let's add more 2 seconds here, and then let's say the service is now releasing the resource. Is releasing the resource. Okay, releasing the resource, and now we're gonna drop the permit to release the semaphore again, so the other services can use that. Okay, that's an async function. Now let's create our main function with Tokio. Here we have a normal main function. Let's turn this function to run asynchronously. Sync. Let's call the Tokio macro, which is Tokio main. Okay, and now let's give a name. Let's define our the number of resources we have. So non-resources is equal to 4. So according to our image here, we have 4 resources, right? And we have 10 clients that want to consume their resources, but we want to avoid them to consume the resources at all the resources we have at once. So at least 4 clients can consume the resources, and the other 6 have to wait their time to consume the resources. So that's the goal here. So number resources is 4. Let's create our semaphore. Semaphore is semaphore. Okay, that's wrong. Semaphore here with the number of resources we have. Okay, and we're going to use our atomic reference counting here to pass this semaphore and share these in a safe way between multiple among multiple threads, because when you are running code with Tokio in parallel, sometimes this code can run in multiple threads instead of one. This is the default behavior Tokio has. So this is to increase performance, but in order to deal with these concurrent situations, we need to use this arc. So we have this resource shared among multiple threads is in a safe way. So let's create this semaphore um, arc. That's going to be our arc new, and let's pass our semaphore here, that arc. And now we're going to create a loop here to simulate. We have multiple services, maybe 10 services. So this is going to be from 1 um, to 10. Actually, something like that. And we want to spawn um, async functions to run concurrently here. So I'm going to use Docker to spawn that that function access to run concurrently here. So let me call Tokyo is spawn. So this expects a feature, so we can call our access function, that is a sync function. This is expecting our semaphore, our resource is, and also our services. So this is an arc. We want to clone it, um, and want to use our arc here instead of the semaphore directly. And the resource, we want to pass resource database reference, and for our services we can just pretend we have some services here. So server C and service, that's just going to be a number, service 1 and 2 and 3 and so on. So yeah, and then we want to wait and unwrap. Okay, there's something wrong here. Let me remove this piece of code. Let me see what's going on here. Semaphore. Here's missing the method that's new. So I need to call. I have to call semaphore new. So to passing the number of pyramids I want. Let me call cargo run here and see the results. So service 1 is waiting to use the resource. Service 1 is releasing. Now service 2. Now service 3. Service 4. So let's wait to see if all the services are going to use the resource, are going to consume the resources correctly. service 7. So just to let you know, those services are not exactly running in the same order. They are being spawning here. Sometimes that's gonna happen, but sometimes that's not gonna happen because Tokio can spawn multiple threads and then can run and execute in different orders. So order is not ensured here. So yeah, our 10 services consumed the 4 resources we shared, and they work in a way as they were in a line waiting for their time to consume the resources instead of consuming everything at once. So you can use this to share, for example, a pool of database connections or other things. They are expensive and limited resources you have, and you can trust this Semaphore to deal with that and run your code concurrently. I hope you liked that, and see you on the next video.